So yeah, I have the pleasure to introduce Fishbones technology to you. It's actually a company that has a proven track record in the E&P industry, and we think there are a lot of similar challenges also in geothermal. And therefore, we want to enter the geothermal market and also do a kind of a partly energy transition. So Fishbones will stay in the E&P sector, but we will also enter the geothermal market. I myself just joined this great team of people only 2 months ago. So I'm learning about the technology every day by myself. So please bear that in mind when you fire up your questions afterwards. So yeah, Fishbones technology, I think the first slide will already help you in understanding why we are called Fishbones, because actually this is a very unique stimulation technology where you build like channels perpendicular to main well bore. The stimulation technology is being run and part of an open hole liner completion. And it is composed of needles that are stiff and made out of titanium, and they are activated and operated by means of a pumping job. So you need a certain pumping rate and pressure, and so these needles are being pushed out, and they always build up the same angle so that they end up perpendicular to the main wellbore, and they reach out about 9 to 10 meters around the wellbore. And you can place numerous, so one sub of a Fishbones stimulation part comes with either 3 or 4 needles. I will show you the technology in a few slides in a bit more detail, but you can place almost as many subs as you want, depending on the extension of your reservoir, and if you're drilling vertical, deviated, or horizontal. And all those needles can be activated in a really short time. Usually it takes only a couple of hours to drill out from the main wellbore. So my presentation will be divided into 3 parts. So I will further introduce the company to you, the technology, tell you a little bit of how it started and where we are today. Then I will show you some selected success cases from E&P, where I think, or we think, there are similar challenges in the geothermal market. And I will conclude with a very brief outlook on geothermal. So actually the vision of Fishbones is to be the first consideration for stimulation of reservoirs worldwide. And to get closer to this goal, we have so far developed 2 different systems. A jetting system that is composed of 4 needles that can be jetted out from one sub, and then the further advancement of this technology is the Fishbones drilling system. So the jetting is very successful, deployed in different kinds of carbonate reservoirs, and the drilling system can actually drill any formation. So far, we have not experienced any limitations with regard to formations. We have these 2 systems available in 2 dimensions up to now, 4.5 and a 5.5 inch liner, which makes it suitable for 6.5 to 8.5 inch open holes. However, this is not the maximum. It can go up to 9.9 inch, which is sometimes also worth the consideration in geothermal settings, because of the high flow rates, you might need bigger diameters. And I can explain maybe, because I will focus more on the drilling technology today. Also my examples I will show you later on from experience from Fishbones drilling, because I think this is which is what is mainly interesting also for deep geothermal systems. And on the right side, you see that the drilling system with the 3 needles, each needle has been driven by a turbine. And at the other end of the 12-meter long titanium needle, you have a tiny little drilling bit, which is of the size of 12 millimeters, if I'm not wrong, and it drills a hole of 13 millimeters to give you a bit more about the dimensions. And these needles, as mentioned before, are placed inside a liner and then activated by differential pressure and pumping rate. So a little bit about the history of the company. So most of you come from Norway, so maybe the inventor or the guy who had the initial idea about Fishbones was Rune Freyr. I might pronounce it completely wrong, but some of you might have heard of him. He's a serial entrepreneur here in Norway, and so he had the idea about a stimulation technology without lots of fracture fluid required, and also to have a really controlled and low environmental impact stimulation method. And it took almost roughly 8 years from the idea to the first project. That was between 2005 and 2012. And the first Fishbones jetting installation installed in a commercial well was realized in 2013. However, at some point, Fishbones realized that they were not able with the jetting technology to go through really hard rock, which is why, based on joint industry projects at that time with Equinor and at that time Lundin, now AKBP, ENI, the Research Center Norway, they further advanced the jetting technology to the already introduced drilling technology, and the first commercial well with Fishbones drilling has been achieved or realized in 2015. Since then, a lot happened. So Fishbones expanded its geographical footprint, installations grew by every year. And last year, we opened a regional hub kind of in Abu Dhabi, because there we are very successful with the jetting technology. And Fishbones also started already discussions about opportunities in geothermal, which is why they decided last year to enter into the German geothermal market. And as of today, we are 40 employees. It's a great bunch of very skilled and diverse people. We have 40 nationalities. It's really fun to work with all these experienced and diverse people. We have coming up several installations in 8 countries spread over 4 continents. We wrote, there are many SBE papers published, so just contact us if you are interested. And yes, and then I was hired as a new resource responsible for business development in geothermal. And here you see a map of Fishbones in green, like where Fishbones is already installed, and some ongoing projects marked in yellow. And you also see where we have in some way a presence in the country. Let it be Fishbones direct employee, or we are working also with agents around the world. Our biggest markets is, I mentioned it already, Middle East, and here in Norway, the North Sea. However, we also see huge growth potential in Mexico and China, for example. And some hard numbers of our proven track record. So far, 40 installations have been realized globally, and the maximum numbers of Fishbone subs installed in one well is 61. This was the Fishbones drilling system. So if this number times 3, it's, I think, 183 laterals that have been installed in one well. We have the longest horizontal section is 2,675 meters. And we are also able to install Fishbones under quite harsh conditions, like in China. There was a well, I will show it later to you, where we installed Fishbones in up to almost 5,500 meters of depth and 190 degrees centigrade. However, we think this is not a limitation. We can go higher with regards to temperatures and deeper with regards to the depth. Applications to date, there are actually not many limitations regarding applications. I mentioned already we are able to drill almost any formation. Fishbone so far is proven in the EMP sector, which means we have Fishbones installed in mainly in oil and gas producers, but also in some water injectors. And with regards to well completion or construction methods, there are also not many limitations. As far as I know, one limitation is Fishbones cannot be run with a gravel pack or cement, but we have run Fishbones already in a combination with sand screens, where it's just important to have some inflow control devices. And the value of Fishbones, again, coming from EMP, but here you see already that there are similar challenges in deep geothermal. So with Fishbones, you increase reservoir exposure. You can connect layered reservoirs. Also, connectivity is a big thing, connecting to natural fractures. A big advantage is that this stimulation method is very controllable and accurate. So you can bypass damage zones, you can reduce drawdown. This is, I think, also interesting for geothermal, because in some cases, or in many cases, you need an ESP pump, and reducing drawdown makes operating an ESP pump probably more efficient and cost effective. So this is a benefit. And of course, what is not mentioned here is also that you reduce the already mentioned risk of induced seismicity as well. However, what has to be said, like you saw, like these needles are 12 meters long. I mentioned already that the reach out from the main wellbore is about 9 to 10 meters. So you rather increase your wellbore radius, but of course it's not like that you would create extensive additional surface area like it would be realized with hydraulic fracturing. So this is not the same. Just a picture, yeah. Oh, okay. Just a picture how these needles are physically placed into a liner, and on the second one you see where these needles with the small drill bits come out. And now I will come already to a few success cases from EMP. The first success case is actually the first well in which the Fishbones drilling system was installed here in Norway, in the Åsgard field. Equinor was the operator, and the challenge here was that the reservoir was quite thin, only 30 meters thick, and it was also quite tight sandstone with the cement strings, so reduced vertical permeability. And there was a need for very accurate stimulation, because this reservoir is underlain by an already developed gas field. So hydraulic fracturing was not an option in this case, and the solution provided by Fishbones was the 5.5-inch liner with 48 Fishbones drilling subs, translating in 144 laterals that have been drilled from the main wellbore. And this Fishbones installation was made in a dual lateral well, which means Fishbones was installed in, I think you can see this on this next slide, in the main wellbore, which is on this schematics, the lower one, and they had a lateral which was completed with a standard pre-drilled liner. Both both laterals had very similar reservoir properties, so that was extensively analyzed via logging parameters, and then they could compare production rate based on tracer experiments, and the results were that 2/3 of the production came from the wellbore that was with the Fishbones installation, which means we doubled the rates in this way. And yeah, this is a summary from a presentation Equinor gave at the Norwegian authorities here, where they mentioned that they were very happy. Another well has been drilled, which also came in as expected. And a next well is also coming up. And they said that, yeah, you can read it here, that Fishbones is a solid business case with a low cost and no apparent downside risk, and that it's very favorable in low permeability reservoirs. The next case is what I already mentioned before, under harsh conditions, a well in China. Here we installed Fishbones drilling in a fractured gneiss formation. So we were able to drill that in almost 5,500 meters depth. That was a vertical well and with 190 degrees. Here the 4.5-inch Fishbone system was installed, and yeah, it was again a successful deployment. The drill out took 5 hours to drill out the laterals, and we had almost 70% of increase. And so because of the success, more wells will come up this year. So. And last but not least, Edward Creek is probably known by most of you. Here, actually, the drilling system was further advanced also through a joint industry project, because the challenge in this field is that reservoir properties vary a lot, and also the lithology. So you have in parts unconsolidated sandstones where sand screens are required, but you also have very hard formation conglomerates, granite, so very hard to drill. And Fishbones was installed again with a 5.5-inch system, and at that time the operator Lundin recognized a 10 times increase in productivity, which also then of course led to follow-up projects. There is an SPE paper available on that case, and soon another well will be coming up. This is just an extraction from the website from Lundin. I'm out of time already. Okay, yeah, I will. So then we skip this. It's just that they mention again the 10 times increase. And now what's up for geothermal? Actually, the status is that Fishbones already made a market study in 21, quite basic, and we are in continuous communication already regarding several projects. However, so far no well has materialized, which is also why Fishbones decided to really hire a dedicated resource. And so my job is now to screen the market, understand the technology, see where is the best fit for Fishbones, where can we make the difference, where can we bring value to geothermal wells. And yeah, and like here's my first presentation today, and it's important to spread the word. Fishbones is already well known in the E&P industry, but not so much in the geothermal sector. And yeah, we want to secure a first well to really show that we will also bring value to the geothermal market. And with that, I conclude. Thank you.
Thank you. Thank you, Kerstin, for a very interesting presentation. So, any questions from the floor? Yeah.
So, but time is still an issue, right? Any time. You said 5 hours, but that's for each sub in a way. Can you drill out all the subs?
Yeah, we can drill out all subs simultaneously.
Okay.
So, yeah, it's pretty cool.
Very
That's why I joined the company.
I don't know if you were before Anders first, then Ulrika.
I mean, or maybe to expand a little bit on that. I mean, we do, what I didn't mention is how is a process being done. So we get in contact with the client, and we always need information about the reservoir. So reservoir properties are very important, and then we do also some simulations. We work together with a consultancy company in the Netherlands, and we have a modeling tool, SimFish. It's a very simple MATLAB tool, and we simulate what Fishbones can bring as additional value. And we also always ask for core material, which would be the best, or really analog material, because we do lab scale experiments, because the rate of penetration is very important. We need to really find the right design to drill out the needles. And so the time varies a little bit, but usually it's around these kind of, I think, 5 to 6 hours. And if not, please, my boss is sitting right there at the corner. If I say something wrong, please raise your hand. But I think, yeah, this is the time.
Very, very good. Okay, Ulrika, last question. I think we need to move on. So please, yeah.
Oh no, the costs again. Please no.
I was just wondering about the bidding of the meter. Please clear that, or is it done at the same time for all the meters down hole, or how do you?
Yeah, actually, these needles are stiff, and they, as mentioned, I'm not a drilling engineer, I'm not a reservoir engineer, but they are being activated by this pumping rate and pressures, and they are made because they are so stiff, and they have always the same angle going out of the fishbone sub, and then they always build up the same angle. So they don't go in different direction. And actually, as I mentioned, we want to be the first consideration for stimulation worldwide. We are trying to further advance the system. For example, one interesting advancement when you think of fractured reservoirs is to really be able to orient the needles in the wellbore. So far, we have like these needles are faced by 120 degrees and they go out, but we do not know the really exact position in the well. And this is what we are working on to further advance this technology.
Very good. So thank you very much, Kerstin.